All right. So your topic here is fake news detection using advanced NLP techniques. So I will expect that you introduce this topic as okay. Maybe after welcoming them, that okay, maybe good morning, everyone. Right. My name is I don't know. So this was what the team put here. My name is Jimo Ayodele Musibao, right? And I'm here to um give a presentation on my MSc project titled Fake News Detection Using Advanced Natural Language Processing Techniques, which is the NLP techniques. Okay.
Okay.
And we may wonder why detecting fake news. Why does it matter? Why does detecting fake news matters, especially nowadays, right? So one is on from the political angle, which is we know that accurately detecting um, fake news can help protect democratic integrity, right? Because there are a lot of misleading information out there, especially during critical events like election, which can prevent the manipulation of public opinion and ensure fair political discourse. So accurately detecting those fake news can help prevent the manipulation of public opinion. Another one is just to prevent the societal harm that fake news could actually result to. So accurately detecting fake news, especially early enough, can help us prevent the propagation of false information that could potentially harm individuals and societies at large. And our third on the list here is to enhance public trust, right, in the information out there. We're in an information age. We're in the social media era age. So we want to be able to have trust in the information out there. So accurately detecting fake news, right, we increase the reliability on the public news, on social media, and even out there. So that we can help restore and maintain public trust in the information ecosystem. All right. So these are few points why I'm actually choosing this topic to focus on for my MSc program. All right, so next I will be talking about some existing methods, some traditional methods that have been used to detect fake news, and also the limitations of some of these methods. One of the methods that have been used are the feature-based methods. Now, the challenges here is that, or the limitation here is that this method is a manual method, right? So it involves manually engineering features, right, to capture the information in a specific text. So, but manual method or rule-based method, they are not like they are limited in the sense that, right, they cannot I mean they cannot capture the complexity in the fake news out there, because they are working on based on some features. For instance, they are working on they could be using maybe the structure of the text, or maybe this manual method could involve detecting that a particular text is fake based on maybe the kind of maybe text that involve numbers, or maybe text that involve a particular maybe uppercase letters. So they failed to capture fake news in more complex information. We know that fake news may not have those features, so this manual method may fail in such scenarios. Some other method have used traditional machine learning methods. But this traditional machine learning method, they often lack the ability to handle the complexity, the semantic subtleties and in present in natural language. So they are not able to capture the right the complexity of this fake news. So to be able to accurately detect them. So with these few limitations, this poses a challenge, and that really tells us that we need a more advanced NLP techniques method that should be used to detect fake news. And so this leads us to these two research questions. And say, okay, how do traditional machine learning methods that have been used in the past compare to a more recent deep learning and NLP techniques in terms of handling the semantic subtleties and context present in natural language for fake news detection? And also, another question we're interested in answering is how effectively deep learning models, particularly those ones that involves pre-trained models in transformer models like BERT, can help improve accuracy of fake news detection. So these are the two research questions that this work aim to answer. And the solution we propose to answer the first one, we built several models, including traditional machine learning, deep learning, and BERT models to detect fake news in our dataset. Also, because we want to undo the semantic subtleties in the data, we developed topic models to identify diverse themes and compare with the news tag present in the news dataset. All right, so this is an overview or an architecture of the methodologies of this work. So given the news data that we have, it went through a lot of data pre-processing, which we're going to talk about in a couple of minutes. And then the cleaned data is what we built several models on. So we have a baseline model, and then this model, we tune them doing some hyperparameter tuning. And then we also built some recurrent models on them and a BART model. And each of these models helps to predict whether a given news is fake or real. All right, so just a little bit about the data set that we use for this task. This data set comprises of over 12,000 news articles, which we obtained from the Kaggle platform with 6 new labels as listed here, right? We have the true, half true, mostly true, false, barely true, and unknown. And to improve the result of our models, we augmented the data set with additional over 66,000 news articles, which contains only true and false labels. So because this new data only have 2 labels, unlike the first one that has 6 labels, we merged them together. Like in the previous data set, the ones that contain the true, half true, and mostly true, we label them as true label, while the false, barely true, and unknown, we merge them as the false label. So now we concatenate the two data sets so that we now have only 2 labels, and the entire data set is now over 79,000 news articles. And this is a distribution of the label, the target in the data set. Our target is to tell us whether the news is fake or real. So we can see here that we slightly have more fake news in this data compared to the real news data set. And this is just a word cloud of the data set just to tell us the fake news and the real news. If you look at this you see that even from here, we looking at it, it is very hard to see the difference between the fake news and the real news. They are almost the same. Look at the word say, state. They all stood out here, percent, year, job. They all appear in both of them. So even as human, it's difficult for us to identify which one is fake, which one is news. And we could assume or hypothesize that our model will also struggle to understand which one is fake and which one is news. This is why we need a more advanced technique to help distinguish this. So before we build the model, we use some word embedding. We consider some word embeddings. So word embeddings is a method for representing words as vectors in high-dimensional space. We use both the traditional and the pre-trained one. For the traditional, we use the bag of words. We also use word embedding technique like the TF-IDF, and we use a pre-trained word embedding like the word2vec on our data set. All right. So after converting the text to numerical format, we built several models on them. So for our models, we considered our models are in both supervised and unsupervised. The unsupervised are the topic models, but for the supervised, we considered quite several models like the tree-based models, linear models like the logistic regression, naive-based, and even recurrent models and BART models. And for the unsupervised, like I said, we did the topic models like the LDA, the NMF, and the BERT topic to capture the things in the data sets. Okay. So for our model, for the model that we built, right? So we like I said at the beginning that we did word embedding. So we tried these models on each of the word embeddings. So this is a performance of the random forest on the 3 word embeddings, the bag of words, the TF-IDF, and the word2vec. The bag of words and the TF-IDF, the random forest seems to have exactly the same. But since from research, TF-IDF seems to be a better option compared to bag of words, we decided to go with the model performance on the TF-IDF. Same thing with the gradient boosting on also the 3 type of embeddings. The bag of words and the TF-IDF, the gradient boost achieve exactly the same, but because of the performance, because of the research justification of TF-IDF being better than bag of words, all the other models were trained using the TF-IDF. So all of these models were trained using the TF-IDF embedding. As we can see from the performance, BERT seems to perform better than all of that with a 92% F1 score. Now the baseline here is one of the related work, which also did fake news detection using data sets similar to what we used for this work. However, our model performed far better than this related work, SBAKE, showing that our work, this work is actually a contribution to the field. And for the unsupervised learning, like I said, we built 3 topic models, the LDA, NMF, and BERT topic. And we evaluated the topic models using the topic coherence. Now, topic coherence is a metric which is normally used to assess the semantic relationship among words within the topics. So based on these 3 topic models, BERT topic seems to perform the best. Right. So in conclusion, this work contributes significantly to the field of fake news detection, presenting an extensive exploration of machine learning and deep learning models for fake news detection. We identified the LSTM network as a standard performer, which emphasizes potential of deep learning approaches. We fine-tuned BERT on our data and it achieved an F1 score of 92% in detecting fake news. So the BERT models is our best model here, and it also outperformed the baseline model. And we also incorporate topic models to compare discover teams with the new start. Thank you. So, all right.
Yeah, it's nice. But the
So,
time frame, is it not too short?
how many
Okay,
minutes are you given
30 minutes.
to? No, the 30 minutes will include question, or is it 30 minutes to present?
Okay, to include question. Yeah.
Did they include question?
The whole presentation is 30 minutes. So I'm like looking for maybe to
So
expand
the
more.
whole stuff is 30 minutes, right?
Yes.
Which include question.
Which include questions.
So your
So
plan is to present for 20
for
to
like
25
20,
minutes.
25 minutes. So the question will be limited. So it won't be
Yeah, so if you are going to present, I am
okay.
very sure you are going to take more time than I am.
Definitely.
I am so sure. So
Mm. Yeah, you perform very, very well. Thank you for that.
So
Seriously.
what I can do here is I recorded this, so
Okay.
I can share the recording with you, so you can also listen to it
Mm.
and watch and over and use that to practice before your presentation.
Yeah, thank you so much.
Mhm.
Yeah, I
So
appreciate it.
yes, you have any questions?
Mm? Yeah, for me, I didn't have question on this, but at least from their hand, we might be like asking for like the challenges facing in getting this data. I mean, this whole work done.
Mhm.
That would be like a question like, what are the challenges facing during this work?
Okay,
What are the hurdles?
so there are a couple of things you could. Oh, you have to download the slide.
We to download it, but
You
I'm
can
still
re-download it because I just changed something here. I think they made a typo here. It's supposed to be data sensor or specifically put in tweets. That's slide 11.
okay. Yeah, I saw it there too.
Yeah, because that says not tweets. Yeah, I don't think
Okay.
it's tweets. I'm not sure. I don't think it's tweets.
Mm.
Okay, so well, there are a couple of things, challenges that will arise. One, getting the data set here. Like one of the challenge is computing a challenge, especially with models like BERT, because I know the team told me on this that are you going to pay money for computing? So you can talk about BERT. So running BERT on 79,000 data set was
Consumes a lot of memory. Yeah.
a
Yeah.
lot of
Yeah.
memory. So you use Google Colab. Do you know about Google Colab?
Yeah. Yeah. Yes.
So even Google Colab crashed because you're using the free tier Google Colab. So
Mm.
you run out of memory. So uh you had to switch between you were switching on between local Jupyter Notebook and Google Colab, meaning when it ran out of memory, you had to download your notebook, run it locally, and we could only run the BERT for just one epoch, meaning one iteration.
Okay.
Ideally,
Attrition.
ideally you could have run the epoch for like 5 to 10, the bed for like 5 to 10 epochs. But because of the computational limitation, you have to just use one epoch. So that's one major challenge that you encountered here.
Okay. The another question is, what parameter did I use for cleaning the data? Getting it
Okay,
cleaned.
I mean, cleaning text is something straightforward, right? So not really
Okay.
straightforward. Like, so you use a tool. So there is a common tool you use all these tools, natural language NLTK. So NLTK is a package that you use to clean the text. So in NLTK, you use a lot of functions and modules there, like the stop words to remove stop words. All of these things were actually explained in the report. So yeah, they're actually in the report. You need to read the report. Yeah, I'm not sure. Do I have access to your report? Let me see. Okay, I think I do. All right, so if you come to the report under data pre-processing, See, all the thing on data collection that they're all from here. So you should
Okay.
read the report very well. So you see text preprocessing. So as a
Yeah.
first step, we remove any missing values and duplicate from data set. These are some of the text, these text processes with HTML tags were removed, right? Digits,
Okay.
numbers, they were removed. All text were converted to lowercase, that's small letters. Then we did
Okay.
organization, commonly used words. These are what we call stop words. They were removed and text normalized. So this was the data preprocessing that was done. And the tool you used was the NLTK, Natural Language Toolkit.
Natural language kids. Okay.
Yeah. Okay. Any other question?
Mm, and now that's what. Okay. Okay. Yeah, you didn't talk on the RNN, the recurrent neural network.
Which of them? The RNN
Yes.
is here now. Simple RNN, LSTM. These are recurrent neural network. I talked about it that you did see RNN here. Talk about recurrent neural networks here. But the reason no emphasis on it is that the BERT perform
Okay.
better.
Outperform that. Okay.
Yeah. Then I also talked about in the conclusion by saying we identified the LSM net as a standard performer, which emphasized the potential of deep learning approaches. LSTM is also recurrent because if you look at it, well, though even the LSTM, the recurrent, they are not very, the gradient boost and logistic regression will perform better than. So BERT is the main focus here
Okay.
because that's the one that performed better, and that's why we highlight it.
Okay. Okay. Thank you. So the F1 is the.
That's the metric that was used to judge the performance of the model.
Okay.
So the question is why F1? So you could be asked, why not
Okay.
accuracy, or why not
Well.
recall, or why not precision? So we use F1 because for imbalanced data, so if you look at this, this is an imbalanced data. The fake news is higher than is more than the real news. So for this, using accuracy is not a reliable metric. So a metric that is reliable and that can
Okay.
give us the true picture, the true performance of the model in this, when there is imbalanced data like this, is the F1 score.
Okay.
Yeah, an F1 score is just a combination of your recall and your precision.
Yeah. Yeah. Okay. Thank you.
Yeah.
I think I can go. I can do it now. At least, even with this, we're running up to 30 minutes now. So,
Mhm.
and I believe at least. Thank you. Thank you so much for everything.
Yeah.
It looking more easier for myself.
Yeah. So my advice would be to first watch the recording that I will share with you and
Okay.
practice presenting it to yourself back
Okay.
to back so that you can be familiar at least 3 to 4 times
Times
to back,
before the
and
time.
then
Okay.
go back and read the report.
Mm,
You may not focus on introduction, the methodology. Focus
okay.
on the methodology, and then yeah, the main thing is the methodology.
Mm,
And when they are asking question, if the question is from the slide, you can scroll to the way to the slide
the
they are asking question on, so that way you don't say something different.
okay. Okay.
Yeah, if they ask question on, let's say, methodology, you can scroll, can move back to that slide.
Okay.
Yeah.
Mm, okay. Thank you.
Okay. So
I
yeah,
work on it.
no problem. So I will share the recording with you. Yeah.
Okay.
Mm,
Thank you.
no worries.
Yeah.
All right. So success.
Okay. Thank you, man.
All right. Now, yeah.
Thank you.
Yeah. Bye.
Bye.